You're here because you want to master chemical bonding with a University of Cambridge graduate. Let's begin. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. So before we start on chemical bonding, just a quick recap from the atomic structure chapter. Remember, why do atoms actually do bonding? They actually do this to achieve the stable octet configuration. So atoms either do ionic bonding, where they lose or gain electrons to form ions to achieve this stable octet configuration, or they can do covalent bonding, where they share electrons so that they can still individually achieve their stable octet configuration. Now let's talk about ionic bonding first. In ionic bonding, it is between a metal and a non-metal, right? And these metals generally lose electrons, and the non-metals will generally gain electrons. Now a hint is to see what is the most common ion for a particular element, you can look at the periodic table. To determine this charge, right, you generally want to look at the group that the element is in. The group is basically the column in the periodic table. If it is in group 1, it tends to have a +1 charge. If it is in group 2, the metal tends to have a +2 charge. If it's in group 3, the metal tends to have a +3 charge. Okay, and if it's in group 4, right, this is not commonly asked, but they could have a +4 charge. And if it's in group 5, this is where we enter the non-metal territory, right? These tend to have a -3 charge because they gain electrons. Okay, group 6, okay, they have a -2 charge. Group 7, a -1 charge. Alright, and if it's in group 8, they tend to not have charges, okay, because they don't tend to form ions. This is because group 8 is what we call our noble gases, right? And these noble gases already have a stable octet electronic configuration. Next up, we want to learn how to draw our dot and cross diagrams, right? Because it's actually a very essential skill because it's always asked during the test papers and even the final year exam papers, how to draw a dot and cross. So please master this skill. For ionic bonding, right, you want to look at each of the individual elements first, right, and pay attention to each of their electronic structures. For example, we know that sodium is the metal, for example, and it has an electronic configuration of 281. Next, you want to draw the rings around the element itself. Right, as you can see over here for sodium, it has 3 rings because it has 3 electron shells. Next, you want to fill each electron shell based on the number of electrons. For example, if it's 281, then the first electron shell will have 2 electrons. The second electron shell will have 8 electrons. And then the last electron shell will have 1 electron. Okay, and you're not done, right? You want to know what actually happened to the electronic structure. For example, sodium, where it will become a sodium plus ion with a 1+ charge. And because of that, it actually loses 1 electron. Alright, and this 1 electron will actually be given to a non-metal to form an anion. This would end up creating a new dot and cross, right, where because of the new electronic configuration of sodium, right, it will have a 2.8 electronic configuration instead of 2.8.1 because it lost the 1 electron. And because of that, it wouldn't have a third shell. So when you're drawing the dot and cross for the ion, right, you don't need to draw the third shell itself because it's empty, it doesn't exist, right? And it will have a square bracket and a plus charge that is always written on the outside. Do take note, charges are always written on the outside itself. Now let's take a look at the non-metal. In this case, for example, it will be fluorine. So again, we look at the initial electronic configuration, it is 2.7, right? So when you draw the dot and cross for fluorine, you will have 2 electrons in the first shell, and then you have 7 electrons in the second shell, right? And do take note that I've used a circle instead because it will be different from sodium where it has crosses, right? It's called dot and cross, so generally it will be a difference of circles and crosses, right? And because they are different elements, we use the different legends itself. Now, For fluorine, right, since it's the non-metal, it's going to gain the electron, right? It's going to gain an electron. And for F, right, it is in group 7, so we know it generally has a 1- charge. And because of that, we know that it gains 1 electron, because it's 1-, right? And its new electronic configuration will be 2.8. So when you draw the dot and cross for the F- ion, it will have 2 electrons in the first shell and then 8 electrons in the second shell. And do pay attention to the new electron that came in is actually a cross, because as we remember, the electron did come from the sodium ion. So we know that this electron didn't originally belong to the fluorine. So in our dot and cross, please make sure that any electrons gained actually has to be represented by a different legend. So when we put it all together, okay, if we have an ionic compound called sodium fluoride, right, you have to look at each of the individual elements and then draw their individual dot and crosses. And eventually you will get a dot and cross of the compound that will look something like this. We're just putting together the Na+ ion and the F- ion. Okay, next. Now let's talk about covalent bonding. Covalent bonding, right, is between a non-metal and a non-metal. Now, because it doesn't compose of any metals, right, and we know non-metals generally want electrons, okay, but if you pair a non-metal with a non-metal, neither of which is willing to give, so they have to share electrons. So let's take a look at this example over here. Our O2, right, which is our oxygen molecule, right, consists of 2 oxygen atoms. And we know that this oxygen atom each has electronic configuration of 2.6, which means each oxygen actually has 6 valence electrons. In other words, 6 outermost electrons in the electron shell. Then we know that to achieve a stable octet configuration, they actually need 2 more electrons each, right? And the way they will do this, okay, is that they will share, right? So if 2 electrons are given from each oxygen atom, right, they can share them, and in that sense they can mutually both achieve a stable octet electronic configuration with 8 electrons in the outermost shell. When we draw a dot and cross for our covalent bonding, generally we only need to show the valence electron shells. Alright, and don't forget to overlap the 2 electron shells, okay, which is the 2 rings over on top of each other. And with that, the electrons that are in between the 2 electron shells are actually the bond pairs. Okay, these are the covalent bonds where the electrons are being shared between the 2 atoms. Right, as you can see, each atom contributes 2 electrons, so there's a total of 4 electrons, 2 crosses and 2 dots that are between the 2 atoms. Then you have the lone pairs, right? These are the ones that do not participate in bonding. So don't forget to draw your lone pairs. You must always remember to draw them for your dot and cross. So if you translate it to a different diagram, right, your O, right, is actually covalently bonded via a double bond to another O, where each bond, or in other words each line, right, is representative of the sharing of 1 electron each. So you can think of it as like each O contributing their own electrons here, and each O contributing 2 electrons means it's 2 dots and 2 crosses, and it'll be something like this. If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.